how to find the horizontal asymptotes in a rational function. So horizontal asymptotes actually doesn't have anything to do with factoring, but it has to do with the degree of your polynomials, the degree of the numerator and the degree of the denominator. So if you go back and you review back in quadratics, we learned that the degree of a function is the largest exponent. Now, most of the functions we've been looking at has a degree of 2, but that's not always going to be the case. So if the degree of our numerator is less than the degree of the denominator, then you're going to have a horizontal asymptote at y is equal to 0. If the degree of the numerator is greater than the degree of the denominator, then the graph is not going to have a horizontal asymptote. If the degree of the numerator is equal to the degree of the denominator, then the ratio of the leading coefficient is the horizontal asymptote. So you would have one, it would be like this. LC of the top over LC of the bottom. Okay, so now we're going to look at the 3 examples, graphing these functions and finding the horizontal asymptotes. So we're going to go back to function, actually we got a different one. This is one that we've not seen yet, but finding the horizontal asymptote of this function here. So I have x plus 1 over x squared minus x minus 2. Again, because I'm finding horizontal asymptotes, I don't have to worry about factoring. I just need to worry about the degrees. So the degree of the top one, well, it's linear, so it has a degree of 1. Okay, that's x to the first power. The degree of the bottom, it's a quadratic, so it has a degree of 2. So the denominator, the degree of the denominator is bigger. So that means that I have a horizontal asymptote at y is equal to 0. Okay, so now the next one. So x squared minus x minus 2 over x plus 1. So again, in this one, my degree of my top is 2, and my degree of the denominator is 1. So in this one, my top is bigger than my bottom. And so that goes along with case 2. When the degree of the top is greater than the degree of the bottom, then we're actually not going to have a horizontal asymptote. So there is no HA. We're going to be looking at these so that you can get an idea of what these functions look like. And then in the last one. So in the last function, the degree of the top is 1. And the degree of the bottom is also 1. So they're equal to each other. So when that happens, I have to compare what we call the leading coefficients. So I've got to set up a ratio. So it's the leading coefficient of the top over the leading coefficient of the bottom. So my LC on the top is 2. And my LC on the bottom, well, there's not a number in front of that x, so when that happens, it's 1. So I have a horizontal asymptote at 2. Okay, so now you should know how to find your vertical asymptotes, your holes, and your horizontal asymptotes. So let's get to graphing.